Alright, so we're moving on to the back page of that first one. I'm going to jump on the simple machines one. The design process, I'll post a picture of that and the design constraints, project specifications, project objectives. Look back to the PowerPoints to find that, but it's not a problem, so I'm not going to do it on here. Alright, so simple machines, number 3, if my pen would work. If my pen would work. Yep, something went wrong. There we go. I'm assuming we're still recording. So, this is the simple machines section. Even though we already did some simple machines parts, this is just labeled as that, so you know it's on the second page. So draw a picture of a first, second, and third class lever. Label effort, load, and resistance. I should have said distances and forces. It's kind of awkwardly worded. But explain the difference between them. All right, so first, classic seesaw. One side is going to be your effort. Doesn't matter if that's pointing up or down. The effort distance is on the same side. The other side is going to be the resistance. Again, it doesn't matter if it's up or down. And this is your resistance distance. So FR and DR go together, FE and DE go together. That's your first. In a second class, now the fulcrum's not in the middle anymore. For second and third, the fulcrum is on the end. Right? That's the biggest difference right there. So fulcrum's on the end. First is the only one with the fulcrum in the middle, between your forces. For the second, the mechanical advantage is always greater than 1. It's always to your advantage. Because your effort is out here in the end, FE, right, which means all the whole length is DE, and your resistance is somewhere in the middle. So FR, and then the distance from the fulcrum to that force would be your DR. But in this case, for a second class lever, DE, the effort distance, is always going to be longer than the resistance distance, or else it's not a second class lever. It's not. There's another case where your effort is in the middle, closer to the fulcrum than the resistance, and this is your FE, and that's your DE, and your resistance, let's say, is on the end, or at least farther out, and that's your DR. Now, in a third class case, your resistance distance will always be longer than your effort distance. So this mechanical advantage is always less than 1. In the first class, it can be either way. You can make it whatever you need to be. It could be equal if you wanted it to. But second class, mechanical advantage greater than 1. Third class, mechanical advantage less than 1. And it's because of what's positioned where.